Chemistry, this is our next lesson. It's called Chemical Equations. So chemical equations are the centerpiece of the study of chemistry. Chemical equations are a recipe that shows how reactants combine into new substances called products. So on the left side of the arrow, those are called the reactants, and the right side is what comes out of the reaction. They're called products. So they are exactly like what a recipe would be in cooking. The one-way arrow indicates that the reaction moves from left to right. This is called an irreversible reaction. A two-way arrow, as you see now, indicates that the reaction can move in both directions, and this is called a reversible reaction. Here are three ways to interpret this equation. And this is called a combustion reaction. We'll talk about that. It's any kind of hydrocarbon, CH4 compound, or carbohydrate, CHO compound, that's mixed with oxygen. And if you light it with a match or put a flame to it, you come out with carbon dioxide and water. So oxygen, carbon dioxide, and water are always involved in a combustion reaction. So you can read this as one molecule of CH4 and two molecules of O2 combine to produce one molecule of CO2 and two molecules of H2O. So there you see the molecule CH4, two molecules of O2, then you come out with one molecule of CO2 and two molecules of H2O. Or we can view it in terms of moles, and that's the way we're going to think of things going forward. So there's the reaction. So 1 mole of CH4 and 2 moles of O2 combine to produce 1 mole of CO2 and 2 moles of H2O. Remember, a mole is one of those big baskets of molecules, 6.022 times 10 to the 23rd. In other words, it's an amount big enough for us to actually see and weigh on a scale. Or we can view the equation in terms of ratios. What that means is this. If you look at that equation, you can say whatever number of moles of CH4 we have, that's going to react with twice as many moles of O2. This requires a ratio of 2 moles of O2 for every 1 mole of CH4, whatever those numbers are. So if you had 2 moles of CH4, you need twice as many of O2. That would be 4 moles. And what that will produce on the product side is 2 moles of CO2 and 4 moles of H2O. If you had 100 moles of CH4, you would need 200 moles of O2, and that would produce 100 moles of CO2 and 200 moles of H2O. So you can use any numbers that you want as long as the ratios remain the same. So 1 times the number of moles of CH4, 2 times the number of moles of O2, 1 times the number of moles of CO2, and 2 times the number of moles of H2O. A particulate diagram provides a simple picture of the motion of atoms in a chemical equation. The way the chemical compounds break apart and recombine will be covered later in the course. Particulate diagrams show a beginning and final diagram of a reaction. It might also show an intermediate state. So here you see you have the 1 mole of CH4 and 2 moles of O2. And what's going to happen is they're going to smash together. That's literally how chemistry works. And they're going to break apart. Okay, so it looks like this right here in the center. So everything has broken apart. Okay, and then they're going to eventually recombine like that over on the right. And so everything gets put back together as CO2 and 2 water molecules. Now you might ask, when it's in that middle state, why doesn't it go back to being CH4 and 2 O2? And sometimes it does. It doesn't always go forward. It might go back to being what it was originally, but in an ideal chemical reaction, the way we're going to discuss it, it is going to go forward. Antoine Lavoisier, known as the father of chemistry, developed the idea of conservation of mass in the late 1700s. Conservation of mass means that the mass of the reactants before a chemical reaction must equal the mass of the products after the reaction. So this means that if you bulldozed and burned Hoover High School to the ground, the mass of the rubble and smoke would be exactly equal to the mass of the school before it was destroyed. This means that the number of atoms of each element in the products must equal the number of atoms of each element in the reactants. No atoms are created or destroyed, they're simply rearranged, and that's essentially what chemistry is about. Chemical reactions can be classified into one of 5 types. Combustion reactions, which we just talked about, combine hydrocarbons or carbohydrates with oxygen to produce carbon dioxide and water. Early on in the course, this is the type of reaction we'll talk about the most. Combination or synthesis reactions combine 2 or more elements or compounds into a single compound. So this is how you would create water out of 2 hydrogen molecules plus 1 oxygen molecule, and you would get 2 water molecules. You notice that if you count the number of atoms of hydrogen, it's 2 molecules of 2 hydrogen atoms, that's 4 hydrogen, and over on the right side in the water you have 4 hydrogen. Oxygen, you have 2 on the left, and you have 2 on the right. Decomposition reactions go in the opposite direction. They break one compound into 2 or more products, as you see right here. A double replacement reaction substitutes 2 cations with 2 anions. So it's simply the K, which is the cation, the metal, and the Ca, which is the metal in the other, switch places. So now the Ca comes over to join the SO4, and the K goes over to join the I. That's called a double replacement reaction. We will use double replacement reactions to study net ionic equations in the next week or so. A single replacement reaction substitutes a metal element for the cation in an ionic bond. So zinc chloride, ZnCl2, is an ionic bond. And what can happen is the calcium can switch places with the zinc, and then the zinc becomes a neutral metal and the calcium becomes the cation in that ionic bond. So we will use single replacement reactions to study the activity series later in the course. Now there's 2 major classes of reactions. We're going to spend weeks on each of these. One is acid-base reactions, and the other is oxidation reduction, or called redox reaction. So in the simplest terms, an acid-base reaction donates and receives protons. Acids donate protons, and bases accept and receive protons. So as you see right there. So the hydrochloric acid donated a proton to the water molecule to make it what's called a hydronium ion. Oxidation reduction redox reactions transfer electrons. So there you see the calcium and the zinc. So the zinc has lost 2 electrons to the chlorides, so it is deficient. It's a 2+ charge. So what can happen is it can take those electrons away from the calcium, and now the zinc no longer has a 2+ charge, the calcium does, which means the calcium is going to switch places with it. But that's called a redox reaction. It transfers electrons. So redox reactions transfer electrons, and acid-base reactions transfer protons. All right, and that takes care of this brief introduction to chemical equations. We'll be using these throughout the course.